Today's notes are brought to you by the San Diego Zoo, and they are about 12-3 inscribed angles. I want you to cut your paper in half, even though it doesn't kind of look like that in my picture. In the top half, we're going to be taking some notes on vocabulary and writing 2 theorems, and then we'll be going over 4 different examples. Okay, now for some quick review on some important vocabulary. The first thing I want to go over is what a central angle is, and that's really a review, something you already know. A central angle is any angle that has its vertex on the center of the circle. So, hence it's called central angle. An inscribed angle is a little bit different. So besides the fact that it has a different name, take a look at an example. Here's an inscribed angle. Here's another inscribed angle. So then the main difference is that for an inscribed angle, the vertex is on the edge of the circle, and for a central angle, the vertex is on the center of the circle. And that's it. Now we're going to go over 2 theorems. The central angle theorem, which you already know, this is more of a reminder, and this is the new theorem, the inscribed angle theorem. So here's a reminder of the central angle theorem. Here's what it says. The arc created by a central angle is equal to the angle measure of the central angle. So for example, for this central angle B, if it is 52 degrees, then this arc that it creates from here to here is also 52 degrees. The inscribed angle theorem says this. The arc created by the inscribed angle is twice the measure of the inscribed angle. Let's see what that looks like. So if this is my inscribed angle and it is 27 degrees, now that means that this arc is twice as big. That would mean it's 54 degrees. Now we're going to use both of these theorems in 4 examples. Now I'd like you to take a moment to carefully copy down all of these 4 directions and 4 diagrams. Also make sure that every measurement and arc length is labeled as well. Let's begin with example 1, starting off with what did they give us? Okay, so for example 1, they asked us to find A, and I have to first ask myself, what have they given me? I see an angle inside of the circle, and the vertex is on the edge. This is an inscribed angle. That means that this arc is twice as big as this angle. So angle A equals half of 116 degrees. So I'm going to take 116 and divide by 2. Let's see what we get. Looks like angle A equals 58 degrees. Now for example 2. Now they're asking us to find angle A and B. Okay. A is an arc and B is an angle. It's not a central angle, it's an inscribed angle. And right off the bat, I know that the relationship is that this angle is half of this entire arc right here. The arc that goes from here to here. But I don't know either of those measurements. What I do know is this part and this part of the circle. So what I'm going to try to do right now is find out what's left inside of this circle. Now a circle adds up to 360 degrees, so the first thing I'm going to do is ask myself how much of the circle is left to find my angle measurement for A. So I know that I have 360 degrees in a circle, and I have 82 and 60 degrees already used up. That's 142 degrees. So if I subtract these, I should be able to find angle A. So let's go ahead and subtract. Let's see, I have 218 degrees is A, that arc. Now my second step is to find the angle measure of angle B. Now I know that angle B is half of angle A, so angle B is half of this amount. So I'm going to take 218 and divide by 2. 2 goes into 2 one time, the remainder of 0. Bring down my 1, can't go in there, so I'm going to bring down my 8. 2 goes into 18 9 times. So I know that angle B is 109 degrees. And those are my two measurements. Now for a more complicated example 3. Now it looks like we have a quadrilateral inside of a circle, but I want you to look at the inscribed angles here. There's an inscribed angle with a vertex right there. There's an inscribed angle here, an inscribed angle here, and an inscribed angle there. I have to find all of these measurements, and I'm going to start by looking at this inscribed angle right here. Now that inscribed angle creates the arc from here all the way to here. And that arc is made up of 99 degrees and arc A. Now I know that if this angle is 100 degrees, this arc should be twice that. So this arc right here should equal 200 degrees. If that's true, then I can find angle A, because 99 degrees plus this measurement should be 200 degrees. So that's where I'm going to start. So 99 degrees plus A degrees should equal 200 degrees. So if I subtract 99 from both sides, I can find what A is. And you should get 101 degrees for angle A. So right off the bat now, I can say that that is 101 degrees. Now I'm going to clear my screen. So now my given information is that this is 101 degrees. Okay, now let's move on to another arc. Now in blue, now let's look at this inscribed angle. Okay, this inscribed angle creates the arc from here all the way to here. Now again, I know that this arc is 2 times this angle. So what is 2 times 96? That's not quite as easy for me to do in my head. So let's see, 96 times 2, that's 12. 9 times 2 is 18 plus 1 is 19. That's 192 degrees. That means this whole arc should be 192 degrees. That means 192 degrees should be made up of 99 and whatever this arc is. Now even though they're not asking us for this arc, I'm going to look for it because it's going to help me find these angles inside of here. So let's go ahead and find it. I know that 99 plus, I'm going to call this arc X, should equal 192 degrees. So again, I'm going to subtract 99 from both sides. And let's see what we get here. I'm going to borrow from here all the way through. So I have a 3 and I have a 93 degrees. Okay, let's clear my screen now. So now I know that this angle, this arc up here equals 93 degrees. Okay, now I can start to find some other parts here. Now they asked me for this arc right here, and that's part B. So now let's do this one. Now for this one, now that I know every arc in the circle, and I'm only missing one piece of the circle, I can use the information that the arc measure of a whole circle is 360 degrees. So that means that 99 plus 93 plus 101 plus B should be 360. So let's see what I have so far. 9 plus 3 is 12 plus 1 is 13. 9 plus 9 is 18 plus 1 is 19. So I have 293. That's not 360. We knew it wouldn't be enough because the remainder, or what we need, is what B is. So when I subtract from here, I'm going to need to borrow. So 10 minus 3 is 7. 15 minus 9 is 6. That means that 67 degrees is B, equals 67 degrees. Now we're ready for kind of our last portion here. So I'm going to go ahead and change colors. We need to find angle C. Now inscribed angle C is made up of the arc that goes from here all the way to here. And that angle is half of that arc. So let's see how much that arc is. That arc has 101 and 67 degrees. That's an 8, a 6, and a 1. So that means the outer arc is 168 degrees. So half of that will be angle C. That's 84 degrees. So that's 84 degrees. All right, we're getting there. Now, for the very last portion, to find angle D, I want to remind you that this right here is a quadrilateral. And a quadrilateral has 4 angles in it that add up to, you guessed it, 360. So these are the angles I have, 100, 96, and 84, the one that I just found. So that's 100, 18, 280. So what is 360 minus 280? Let's subtract. That's 80 degrees. So D is 80 degrees. I'm going to leave example 4 for you, but I will point out some important information for you. When I look at this angle, and yes, this is an angle right here, this angle hits the circle at exactly 1 point. Now I also want to point out that this line hits it at exactly 1 point. That means that this line right here is also a tangent line. So it's a tangent line which, when you add this right here, creates an inscribed angle. So I'll tell you that angle W is an inscribed angle. All right, use that information to finish your notes, and good luck.